This conference will now be recorded.
Any guess what is happening here? Actually, when we are trying to turn on this, it will turn on now. When we have been trying to turn on that, this VirtualBox was thinking that it has to get that driver loaded. VBox set up something like that driver was there. It has to get automatically loaded. It said that it is not getting loaded or it's not able to find out. So what was the solution? Either you can directly go here and type that command which will load the driver manually, else you can just exit that and restart the thing. So while restarting it will again check, and if it's not loaded it will try to load the driver. So here what I was about to say today was about soft links. Yeah, this is the thing, More Pro VBox TRV. But anyways, it's installed VBox TRV now, and that is why this virtual machine is running. We'll see here what is called soft link and what is called hard link. Anybody has any idea about these two? Anyone can guess as well if you want to guess. Okay, no guesses, no problem. So let's get to know something more about files. You have hard disk. Inside that you have several files. This file, whenever it's getting written on the disk, it has been get generated inode. It's a number. So on the ground within the hard disk you will have inode numbers. It's number given to a file by the operating system, and which is going to be unique inode for one file until unless it's a linked. Either it's a hard link or we'll see. So inode is a number that goes inside the file, and what we see, name of that file inside your operating system. You'll see you don't see this inode, you see the name connected with this inode. So both these information will get stored here in metadata. In normal Windows system or Linux as well, this name does not Yep, this name does not go and display automatically. Sorry, this name is the only thing which goes and displays automatically to the operating system. I know does not go and displays into the operating system because it's a bit tough to understand the file or to remember the file with the inode numbers because it's just a number and you will not be able to remember. So the name is the thing which makes you more relevance along with the file. Okay, so have anybody recovered the data of a deleted pen drive? Anybody has done that, or anybody knows that that thing can be done as well? I'm just asking, general knowledge, nothing much. It has nothing to do with this.
Don't know, sir.
hmm I'm not going to tell the method, but I what I wanted to say is like this information which goes to the operating system when you do the delete this information only which is lying down in metadata of hard disk, this and this information, both information. So when you are doing delete this information, name will move to recycle bin. That's it. Okay. In Windows, it's recycle bin. In Linux, what is that? Can anybody guess what is there in Linux?
Trash, trash.
Yep, we have trash in Linux. Okay. So when you press delete, it goes into the trash. Okay. When you press shift delete, this name will be lost from here. Name will not be here. So it's going to say that from the disk, it's going to get removed this name. But your file is still there. Your inode number is still there. So what happens? This name is gone. So whatever the space is there, it will show that your space is free. And so your space is free. It means whatever the space this file was consuming, it's not claimed by anybody. So it means a new data comes and there is no restriction on writing a new data at this place. You can write anytime new data since this is not claimed by any file. So what happens when you try to recover a file? When you do shift del means shift delete, you will not recover from the recycle bin, correct? So what happens? This file name will get deleted from here. Inode is still there. What you can do is when you access your hard disk through the file recovery software and all, it checks all the inodes number which are present and it will try to recover. Sometimes you might have seen, or sometimes some people might have seen that you may get your data intact. Whatever you have written, let's say you have written 4 blocks, 1, 2, 3, 4. One file is there and which is here with 4 blocks. Another file is there which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 blocks, which is written 10 blocks. What happened is I have deleted this file and this file also. This file also I have deleted and this file also I have deleted. Now what is happening? After that, Let's say you want to recover this file, but before recovering this file, you have written maybe, let's say, 100 GB of movie or 100 GB of big file, any database file also you have written here. Now, since you have deleted this file, and yep, since you have deleted this file and you have deleted this file as well, you will not have access, and this space is free, not claimed by anybody. So operating system knows that this space is not claimed by anybody, so I can write it down if I do have any new data. So first of all, what this operating system does, it will check which are all empty places, I mean empty sectors which has not been used. It will try to write it down 100 GB spaces, and if all got filled, then what it will do, it will try to write down in these places wherever data is already there. So let's say your data is written on this 10th block, and data is written here as well, in this block as well. It's not written in remaining 4, it's not written in remaining 9 blocks. Okay, just forget about this also. Data is written in only this 10th block, not in 9, and it's not written here also. Okay, so after that, after data is written, and if you try to recover this file with any recovery software, when you try to recover this file, what will happen is this file operating system, that recovery software will come and will check the inode numbers. Through inode number, it will try to capture the files, and for this inode, it will have file all these sectors. It has to read, it has to go through all these 10 sectors. For this also, it has to go through all these 10 sectors. It has to go all these 5 sectors. 1 2 3 4 5. It has to go through 5 sectors. Okay, so when it will try to read this sector, it will get the data. It will try to read this sector, it will get the data. Similarly, it tries to read this sector, it will get the data. Let's say if it is trying to read this sector, it will not get the data, or I will say that it will get the data, but this data does not belong to this file. Okay, so either you may get a corrupted file, or you may get, you may be able to see half of your data in your file, if at all application is able to recover your half data. So whatever software you use, any, so any software of the world will never be able to recover this data, and you will not be able to recover this file. But if you try to recover this file, yes, you will get this file intact. There will not be any problem at all. So that is why it is said, if you have deleted something by mistake, let's say file 1, you have deleted something by mistake, and you are trying to recover that, you are trying to recover this file, please don't write anything into the hard disk. Please don't write anything into the hard disk. You never know that if your subsequent write is going to get written on this block, file 1 block, or not. You never know that. So it's better don't write. If you are trying to recover, if you're planning to recover, please recover the file. And after recovering the file, whatever you want, you can do. Nothing to worry about. This is the one way. I mean, this is explanation how recovery software works. Sometime recovery software would be able to give you the name also of the file, and in some cases it will not be able to give you the name. It just gives you the file, that's all. Okay, this is an overall picture. So what I was saying is, like, we are having inode number here, Okay, so let's erase everything. We have hard disk. In hard disk we have file. File is having several blocks. Blocks is having one file will have one inode number and name of the file associated with that inode. So what is called soft link? Soft link is a link of this file which has just a different inode and link to this file only. So when you try to access, so let's say this is a soft link, this is a soft link, this file is a soft link of this file here. So in this case, if you try to access, if you're trying to access this file, you will get this content. If you're trying to access this file, you will get this content. I mean, obviously the same content you will get because this is the original file and this is your soft link. Soft link is pointing to this original file. So what will be the difference in between those? This is going to have a different inode number. Sorry, this is going to have the different inode number from this file. That's the only difference. What is hard link? So I'll come back to soft link again once again to tell some more difference in it. So what is hard link? Hard link is going to have a same inode number. It's going to create one file and it's going to have the same inode number. It's going to link with the same inode number. Okay. So what is the difference now? The one difference here we can see that this is having different inode, this is having same inode. This is soft link, this is hard link. So let's say if somebody asks a question, what happens if we delete this file? If you're going to delete this file, or if you're going to delete this inode number, let's say, what will happen? Don't delete this file. Don't think like that. Just deleting this inode number. If you are deleting this inode number, your soft link is going to link to this file, and it's just a link. So the link in between actual file is broken. In soft link, it's a different inode and it's linking only in between the file name. So when you have deleted the file, your link in between this is lost, and hence you will never be able to recover this file. I mean, you will not be able to access this file if you try to access this soft link. Okay, you have not deleted this soft link. So now what happens in hard link? If you have deleted this file inode is still going to be there because it has a link with this. That is what the difference in between hard link. If you deleted this, okay, fine, no problem. Let's get deleted. But this hard link inode has already been copied here as well. So this will point to this inode again. Let's see the example. So how to create soft link? we have test.sh. No, don't go for test.sh. Okay, so what I've done is I've just created a copy of file dot. I have one file.sh. Okay, what I'm trying to do is, let's see if, let me see the content of file. It's going to copy the D message. Okay, fine. So I will not copy the D message. I will just print something. Let's see. File.sh echo echo. I'm printing from the file. Okay. So now if I am going to run this file.sh, it's going to say that I am printing from the file. Okay. So now how to create a soft link? For creating soft link, ln space -s is a command for creating a soft link. So ln -s and then file.sh and soft underscore file.sh. So this is the source and this is the destination. What is the destination file name we wanted to keep? You can keep it here. If you want to keep it some other place, you can. Okay. Now we see that we have soft.files, soft underscore file.sh also. But you can see that it has got a different color. ls-al if I'm giving, you can see that soft underscore file.sh is pointing to file.sh. You can see that. ls-il is going to give me the inode number. You can see that the inode number for the soft.sh is 8458700000 and here 8409634. It's different. And there is one more information you need to notice here is this is directory, this is directory, this is stash. It means it's just a file. But you can see that this is a link. Here it's a L. Sorry, I should be showing you difference from here because soft underscore file is pointing to file.sh and file.sh we have, this is the inode 8458702 inode for file.sh and here 8458700. Okay, so this is the inode number for this and this is inode number for this. You can see that this is just a link because L is given here, and whenever there is a link, either it will show like this, soft underscore file.sh is pointing to file.sh with an arrow symbol. Okay, this is one thing. Now let's delete this file.sh. Now check. You can see that we have inode number same here, but it's pointing to a file.sh and that has been marked as red. The meaning of this red highlighted part is This is pointing to this file, but this file is deleted. It's not here. Got it? So let's see. You can see that I have just created a file, and I've just created a file, and now I'm seeing the ls-il. It shows that it's pointing to this. Now the red mark has been gone. It means this is already pointing to this file. So you can think that this is just this is soft link is about matching the name. File.sh, it will have a different inode number. Previously 8458702 was the inode number, file.sh. So now definitely this is a different file, 701, and you can see that it's valid. It's showing that it's a valid pointer and it's pointing to this file. So uh, it's just checking the name and giving you the file. Now coming back to hard link. So okay, I have to show one more thing here. Let me enter this hash inverse echo. Okay, yeah, I wanted to show you that if I'm executing file.sh, I'm getting this output. If I'm executing soft file.sh, I will get the same thing because both are pointing to the same location. Okay, if I just move this file or rename this file, I will not delete this time, file.sh to file.sh.bkp, and if I'll execute this, let's see that no such file or directory. If I'm running this, it will show that no such file or directory, but you will still be able to see that that file is still present. You can see that file is still present, but it will complain no such file or directory because this is pointing to file.sh and there is no file called file.sh. Okay, so this is the properties of soft links here. Now let's do something about hard link. Now let's copy file.sh to file.sh. Fine. We have file.sh. Now ln file.sh hard underscore file.sh. ls-l, we have hard also. Yep. So ls space hyphen il. So where is hard file.sh? 8458701, which is the soft link we of file.sh we have created. Okay. Now you can see that the both inode are same here. 8458701, 8458701, and there is no link also. There is no link. Inode is same, but there is no link. So what is the meaning of this? The meaning So what is the meaning of that? The meaning of that is we have a file. For that we have a inode number. We have file. For that we have a inode number. And we have another file. We have the same inode number here as well. So we have data here. We have data here. But so that data is pointing to this inode number. Whatever we were having inode number here. So it's pointing to inode number. It's not pointing to file. If it's pointing to file, you will get a link. If it's pointing to inode number, you will not get a link. If you delete this, if you are going to remove this file, nothing is going to, sorry, if you are going to remove a file, nothing is going to happen because inode number is still there. And that's what I told you, that if you are going to, in previous diagram, I have shown that if you are going to delete a file by using shift del or using rm-rf, it's going to delete the name, but inode is still going to be the same. Inode is still going to be there. And in this case, it's a valid pointer. It's a valid file name because it has a copy here as also with a different name. So nobody will come and write it down here. This space is still claimed by a file. Okay, so you can see the difference, soft link and hard link. Now coming to practical uses. What is the use of soft link? ls user bin, you can see that actual file is placed somewhere, but you will get the command like this. Actual file is, if actual file is here, you'll get the command like this. For Python also it's the same. For Python also it's the same. What is this? Okay, let me grab Python. You can see that Everyone just be there. Actually, I had some problem in my laptop, so I had restarted it. Not sure why it was not, microphone was not working. Not sure why. So I'll be back in a couple of minutes. It's already restarted, so I'll get things back. Am I audible now?
Yes, sir.
Yes, sir.
So finally, thank you. Let me share the screen. Because I'm not saying anything. I'm just trying to share. My screen is visible.
No, no, sir.
No, sir. No, sir.
Mhm. Okay, so anyways, I let me complete what I have started. What I was saying that we can use that. We can use that for creating several soft links. I mean to say, I have shown the bin file, bin folder. You can also see slash user slash bin folder. You can do ls-l slash user slash bin folder. You'll be able to find out that several application is there for separating version. They use soft links. So let's say in system we will have Python, several Python, and you wanted to use only your Python 2.7 as a main Python. So for that, what you do is you create a soft link for that 2.7 Python as a main Python. If you want to use Python 3 as a main Python or your actual Python to use, in that case also you will do the same thing. It's getting recorded only, still not visible. I am audible now. Yep, I think, and it's getting shared also. So
Yes, sir.
ls-al slash user bin, and then I'm going to grep Python. So you can see that here in this window, when you type Python, you'll get this Python 2 because Python is pointing to Python 2, and Python 2 is pointing to 2.7. So, and 2.7 is pointing to 2.7 actually. Obviously 2.7 is going to point here, so Python is going to point to Python 2 and 2 is going to point to Python 2.7. Let's say if I'm installing Python 3 also, dh client -v -v
Sir, please record the sections.
It's already getting recorded, sir. Python 3. So here I'm installing Python 3. Okay. So, I'm just giving an example, and this example may apply on other things as well. So let me see here. You can see that many folders are here. Python 3 is pointing to 3.6, 3.6, 3.6m. So actual file is 3.6 and 3.6m, and 3 is pointing to 3.6. Python is pointing to 2.7. So if you want, you can point now. Let's say if I want to use Python, okay. Now version, if I say no, it doesn't tell me the version. This should tell, yep. So if I type Python and then hyphen version, it's going to tell me the Python version. Now if you are trying to install an application which uses this arguments only, and you are required to give this argument, so what happens at that time? At that time, you are required to change your version from Python 2.7 to Python 3 or 3.6. So what you will be doing, you are supposed to delete this soft link and you are supposed to create this soft link from 3 to Python. Let me, okay, so I think you guys have lost my voice, so let me repeat what I was saying. I was saying that if you are required to give that application, whatever you are trying to run, that application is seeking Python 3 version, then in that case you are required to you are required to remove this Python and you are required to add this Python 3. So let me rm space user bin Python. I will remove this Python. Now ln-s user bin Python 3. Sorry, this is source. I wanted to create from this file, and what I wanted to create, user bin Python. I wanted to create Python. So now if I do ln-s, okay, let me do the version first. You can see that now the same command I was running before that, it was showing 275. Now I'm running it showing 368, 3.6.8. Now if I do ls-al, you can see that Python is pointing to user bin Python 3 and Python 3 is here. So if your application will type Python, if any application will try to access this Python, that application will get Python 3 rather than Python 2. So this is one way to change your Python version. So which I have used soft links, and you should also understand that you also understood here that how yep. So we have seen that how soft link works. Now we know the difference as well in between soft link and hard link. Just give me a second. Yep. So let's see what is encryption keys actually now. So we'll get to know about the theory part here. Not a screenshot. I want this. There is something called as uh, keys. Keys are keys. It's like a lock and key. Normal. The way you think, what comes in your mind is it's the same thing. Am I audible? Yes. Somebody has got unmuted. Can you mute yourself? Yep. So we have keys which you will generate from your Linux system, or you can get from outside as well. So it gets generated in a pair. One pair will have two keys. One key is named as public key. Another one will name as private key. You can share this, but you should never share this. You can share this to anybody, but you should not share this. Sharing
Sir, you are
so
in mute.
yep, you public keys, you can share with somebody else, and private key you should not share. So what happened? And this public keys and private keys, this is going to be unique in all ways. It's never going to be the same. And nowadays, today, everybody uses public key and private key encryptions and public and private key authentication as well. Most of the people, most of the places, this is getting used. So what happened is one key is getting generated, and let me tell you that how authentication works in terms of public and private keys. Uh, one key is getting generated in public key. Sorry, one key pair is getting generated, and public key you are going to keep on your website. Let's say google.com. Mhm. So this google.com is having your public key, and you are trying to log in from your username. Let's say username is Rahul. I have I have logged in using Rahul username, and I have created a key pair of public key and private key. And Rahul does have the account in google.com. Google.com accepts the key authentication method. So what I should do is I should keep my public key in google.com key section, and then I should log in with the same username Rahul to this google.com account by using this private key. So it will, whatever the key we are going to send here, it is going to, google.com is going to encrypt its saved public key. Here public key is saved already. So whatever key we are going to provide from here, this public key is going to get decrypted by google.com. If google.com is going to successfully decrypt this public key, it means I am a legitimate user of this public and private key, and I will be authenticated immediately without any password, without anything. So public key can get decrypted only using its own private key. So this is what the method for encryption and decryption. If you are okay, let's say if you are encrypting some document using this key, public key, it will be get decrypted only by private key. Some people share this public key just for them to have their authenticity. If somebody questions the authenticity in future, they can decrypt the public key using their own private key, and they can show that yes, I am the sender of this email. So okay, let me repeat what I said. Some people, what they does is they send a mail, along with that they send a public key also. Mail, public key. So what happens is, let's say in some future, in near future, somebody is going to say that whether it's a genuine mail or not, or it's came from authentic source, it has not been mangled in between. So just to verify all these things, sender can get this public key and can try to encrypt using his private key, sorry, decrypt his private key, and he will be able to say that yes, this public key is generated with this private key only, and this private key is going to be held only by the user Rahul. So this is a legitimate user of this public key and private key, so it's coming from the authentic sources only. So this is one thing. Okay, one more example let me tell. During the repository yum update or yum install open So we might have run this command in past. Yum update yum install open hyphen server. Okay, we might have run this. So when we are running this command or this command for the first time after installing the operating system, you might have noticed that it will ask for saving a key. Correct? I've told you at that time that it's going to ask for the first time only, and if I press yes, it's going to sit there and it's going to save the key. That's all. And when you next time install, it's not going to do anything at all. Okay, so when we say yes, it's downloading for the first time. It's going to download the package, and for the first time, it's going to download public key also. Public key of the server. Server is, let's say, it has been hosted on excelmedia.com. excelmedia.com. It's just a random repository. I don't know even it exists or not. So it has not even public key of this. Actually, this public key is going to be of the repository, and repository has been given by CentOS. So whatever the CentOS has kept the keys, it's going to be there, and public key is going to get downloaded in our laptop or desktop. And whenever we download a package is signed with this private key. Package is already signed with this private key. What happens after downloading? It checks this public key is going to be the counterpart of, sorry, not public key. Where is the private key? Sorry, this is going to point here. Okay, so all packages are getting encrypted, not encrypted. It's signed with this private key. So sign with this private key means we are giving some part, or we are giving a signature of our keys in this package. So what happens is this package, whenever it gets downloaded, it's going to decrypt, or not even it's going to decrypt, it's going to check the signed key, signed private key here, whatever is lying down, is the counterpart of this public key or not. If both are able to decrypt, it will say that this package is coming from a legitimate source. This is a valid package, and it will install. So this is a one way of avoiding the hacking or avoiding the installation of unwanted softwares from untrusted resources. You can see that we have enabled in repo gpg check etc yum yum.repos.d CentOS base.repo. You can see that gpg check we have enabled. So this is gpg check is actually the key check, and here is the key. Key is stored in etc pki rpm gpg key set of 7. You can see that this is a place where key is going to get stored. This is the file. If you want to see that, how the key looks like, this is the key. I told you this is, we are going to download the public keys. You can see that this is a, you can see that this key is a public key. So this public key is lying down with in our system, which we have got when we press first time Y while doing system update or while doing any of the system package installation from the repository. At that time, it will get downloaded. So this is a GPG key. Yep. So here we already having a public key. Here we are talking about GPG key, and in rep yum.repos.d and that repository configuration file, we have enabled the GPG check. So what it will do, whatever we have downloaded the public key automatically downloaded, our package is going to be cross-checked whether it's the part of counter public key or not. If it's part, it will say that it will not throw any error. If it's not signed with this private key from the CentOS, it will say that this package is not signed. So either it may not install also, or it may throw error or warning as well. So this is enabled for RPM packages. This is enabled for your kernel driver also, and the same thing is enabled for your system boot as well. Do you know that when you enable the system boot, when you enable the EFI boot, this thing automatically comes into the picture. Not package, I mean the public key, sorry, not that. Let's talk here. Public key and private key, whatever is here. This encryption technology and decryption technology comes automatically into the picture when you enable EFI boot. Your operating system will have the keys, sorry, your laptop or your computer will have automatically saved keys by the vendors, and operating system will have the keys. This keys will match by this keys, will get decrypted. If success, then only it boots. If it's not success, it does not boot. So you will not have your operating system, a pirated operating system in this device until unless you have enabled the UEFI. Sorry, until unless you have disabled the UEFI. So what I'm trying to say is, if you have UEFI enabled, you will never be able to install the pirated operating system. It's not like I'm going to encourage installation of that operating system, but this is what the meaning of uh, uh, public and private encryption keys in terms of booting of an operating system as well. But yes, encryption and decryption here, it performs in several layers. There are several layers here as well. Maybe 3 to 4 layers are coming into the picture, which gets encrypted and which gets decrypted while loading the operating system. So now most of the places this is going to happen, and this is happening. Everybody is moving here because public key and private key is going to be unique at any time, at any point of time. It's not going to be the same. So let's talk about, no, I'm not going to talk here. I'm going to give an assignment, or I want everyone to try. Okay, so let me stop the recording.